Hi, I'm Marc Mikulich, Technical Product Manager for Small Character Technologies here at Squid Inc. Today we're going to discuss the mixing tank in our JetStream CIJ printer. And specifically we're going to talk about how we can determine whether or not the mix tank is properly detecting fluid levels inside the tank. All right, if you're wondering what the mix tank is and where it's located, we can open the front door of our printer. And the mix tank is right in the front right-hand side of our machine. This is where our ink and makeup are combined, and this is the fluid that we actually use when the system is running. So we're not actually using the fluid in the cartridges when the printer is running. The cartridges are just for adding to this tank. All right, to explain how the level detection part of the tank works, which is what we're really focused on here with this video, we're just going to pull this tank apart. Now, this isn't something you should have to do when troubleshooting. This is just for visual reference and for an example. The nice thing about the level detection in the mix tank and the JetStream, there are no moving parts. There are no float sensors sliding up and down or anything like that. So really nothing that can get stuck. What we're looking at here is a series of level detection probes. We've got 5 total, and what we have here in the middle, the longest probe is ground, and then we've got 4 different level detection probes. So we have a low level probe, a normal probe, a high level probe, and an overflow. So how this works is when we're adding ink to this tank, when ink makes contact with one of our probes and ground, normally if there's nothing contacting a probe, what we'll see is if we were actually meter this out, we'd see 5 volts. And we'll show you how to do that later in the video. But we'd see a 5 volt signal for a probe that has no fluid contacting it and ground. Once fluid comes in contact with our probe and ground, our ink is conductive. So when it makes a connection here between our probe and ground, it'll drop that signal low. And that's what the system uses, that signal, to determine that fluid is actively contacting this probe. So when we're adding ink, we'll add past the low level, normal, and when we hit high, and we get a signal here, the system knows to stop adding ink. All right, we do have a visual reference in the display we can look at as well if everything's functioning properly in regards to level detection. We can go into the programming and look at where our ink level currently is. The printer does not need to be jetting to do this, it just needs to be powered on, okay? So we're gonna go into our settings page, and then we're gonna go to diagnostic, and then we have mixing tank. And what you'll see is our 4 level detection probes here. It shows green as what probe's fluid is currently contacting, white is no fluid present. So we're at a good level here. Again, high is where the system will add ink to, and it'll stop there. Overflow is a condition in which our mix tank would be too full, and we'll cover that in a separate video. If you're not certain that the system is accurately measuring the fluid level, we can take a more in-depth look at this. So what we're gonna do is we're actually gonna slide our entire hydraulic assembly out the back of the machine, and the reason for that is we're gonna actually take this cap off. This covers the tops of those level detection probes. So we're gonna take this off, and we can actually meter out each probe and see what kind of signal we're getting there. One thing I'll point out too, if you're having issues detecting fluid levels, let's say the system is just always saying the mix tank is empty, but you verified that we're actually getting fluid into the tank. If you're not sure how to do that, please view our troubleshooting for adding ink and makeup to the mix tank. If this is still showing low, even though we know we're getting fluid to the tank, first thing you want to look at is this little rainbow colored ribbon cable that goes to the top of our level detection assembly here. Easy thing to do first, just make sure that's plugged in all the way. So it plugs into the top of that level detection assembly, and then it plugs into a little PCB right here with locking clips. So first thing to check would be that ribbon cable. Okay, before we slide our hydraulic system out the back of the printer, a couple things to be mindful of. One is we're gonna have a pair of screws that hold the hydraulic assembly in place. So it sits on a drawer here. Our screws are already out, but just make sure you remove these first. And then the second thing is, in this scenario, I would go ahead and power off your printer just to be safe when we're messing around in the back of the hydraulic cabinet. All right, we're at the back of the machine. We're powered off. The screws are out for our tray that the hydraulic assembly sits on. So now we can actually slide this out the back of the printer. And really the only reason we need to do this is to get at the screws on the level detection assembly cap. When you slide your assembly out, just kind of keep an eye on your hydraulic lines and ribbon cables. Make sure nothing gets caught. But really we just need it to this point, so we can access these two screws right here. What we're gonna do is remove the screws, okay, and then we're gonna pull this cap off so we can access the top of those level detection probes. When you take this off, it is also helpful to unplug the ribbon cable. That way we can completely remove the cover. Okay, so now we have access again to the top of these level detection probes here. At this point, it's actually easier to just slide the assembly back in. For us to look at the signals coming off of these probes, you do also need to plug this ribbon cable back in. Okay, once we have the core slid forward, again, we've got the cap off, ribbon cable plugged back in. When we slide this back forward, we can go ahead and turn the machine back on and start troubleshooting. Okay, so we've got the hydraulic assembly slid forward, we have power onto the machine, we've got our ribbon cable plugged back in. We can actually now meter out each of these level detection probes and make sure that we're getting the signals that we need. We can, again, use the visual reference in the programming to kind of compare what we're seeing on the display to what we're actually seeing with our multimeter. So we're gonna go back into settings, diagnostic mixing tank, and our system is showing we have fluid up to the high level probe. And now we can verify that with our multimeter. So all we need to do is switch this to DC voltage. And we're gonna put our common probe to ground. That's the middle probe in this assembly. And the first level detection probe we're going to look at is the low level probe. So that's the probe in the very front of this assembly. And if we have fluid present, again, normally without any fluid contacting a probe, we're going to see about 5 volts DC. Once fluid makes contact with a probe and ground, it's going to drop that signal low. So you'll see on our meter, we're at about just a little over 2 volts DC. So this matches up with what we're seeing on our display for the low level probe, which is showing fluid present. Okay, our next probe is the mid or normal level probe. Okay, so we just moved one forward. And again, we're always staying on ground here. And we've got a very similar signal, about 2.1 volts, okay? And that matches up with our display, which is showing fluid present. Okay, our next probe is the high level probe. That is also showing the same signal and fluid present, which also matches up with our display. And finally, we've got the overflow. And you'll notice now we're closer to 5 volts here, which means no fluid present, which matches up with our display. So overflow is showing that there is no fluid that high, which is good. Okay, so this is an easy way just to double check, make sure what you're getting out of the mixed tank matches what we have on our display. Okay, an important part of this level detection process is we do have a reference voltage programmed into the system that the printer's using when looking at the two values we've got for fluid present and not present. The logic is simple. The reference voltage or value should be set in between our 5 volts, again, which is no fluid present at a probe, and roughly 2 volts, which is fluid present. So the reference voltage should be about 3 to 3.5 volts DC, again, kind of in between those two numbers. So what the printer does is if it sees a value higher than the reference, it takes that as no fluid present. If it sees a value lower than the reference, it sees that as fluid present. So we also need to make sure that the motherboard is, or that reference value on the motherboard is programmed correctly. Now, coming from the factory, every single printer should be programmed the same and correctly, but it's still something we need to take a look at. In order to make sure our reference voltage is set properly, we do need to access the motherboard. So what we're going to do is actually drop down the front panel of our printer. There are only 2 screws that hold this in place, one in each top corner. They're just Phillips screws, so we do need to take those out. All right, so the motherboard for the JetStream is right on the back side of this display panel here. So this large green PCB is the motherboard, and what we're looking for, or the test point for our reference voltage, is TP5. So it's way back here on the motherboard. Okay, so we're going to take a look at this and see what our reference voltage is calibrated to. Now you do also need a ground reference. There are a few of those on the motherboard. For our test, we're going to use the ground right here, and any of them are okay. So we've got ground and we've got our test point. And our meter is still set to DC voltage. Again, we're looking for roughly 3 volts to 3.5. Anywhere in that range is going to be okay. So if we look at our multimeter, we are exactly at 3 volts DC, which is perfect. If for some reason it is not 3 volts, let's say it's only 1.5 or it's 6, whatever it might be, we do have a potentiometer that can be adjusted for this reference voltage. And that's right here. And that's P8 for reference, potentiometer 8. So it is labeled, very, very small label on the board up here in the corner. Again, P8. Okay, so if we rotate the potentiometer clockwise, that's going to decrease our reference voltage. So as I'm turning it clockwise, you'll notice on the meter we're going down in value. And naturally, if we go counterclockwise, it will bring our value up. So again, right around 3 volts is perfect. If you're a little bit higher, that's okay too. But this is what we want to see. This verifies that the reference voltage is correct and the rest of the level detection should work properly. All right, once you've verified that the reference voltage is calibrated correctly, we just need to secure this front panel. So again, just swing it up, and we just need to make sure to get these screws back in place. All right, hopefully this video has helped explain the operational theory of the level detection part of the mixed tank assembly, how it should be calibrated as far as the motherboard is concerned and that reference voltage, and how this works. If you're not sure how getting fluid to the tank is happening or how that works, or if you're having problems with that, make sure you view our video regarding troubleshooting adding ink and makeup to the mixed tank. That's also an important part of how all of this works. If you have any other questions on the system, make sure you view our other videos on YouTube. Subscribe to our channel. There's a lot of good JetStream videos and videos on our other products out there. And also, please make sure to visit squidinc.com for additional information on our products. Thanks.